Right. When we are looking at the random variable, there are two types of random variable we had. One is a discrete random variable. The other one is a continuous random variable. Always discrete random variable, the values are countable. And also how many values the random variable is taking, we can find out. And for the continuous, the values are uncountable and infinite. For each and every point in a certain continuum, there is each and every point is possible. So in that case, we look at two types of random variables. Then when we are looking at the probability distribution, it's a distribution. It lists all mutual numerical values of a random variable and its corresponding probabilities. It's that by a table we can list for the discrete probability distribution. To present the discrete probability distribution, there are four methods we can use. One is listing. There it's like sample points we will put as a pair of each and every point with a particular value of a random variable and the corresponding probability. And then we can use the table and also we can use a graphical method and the formula method. These are the four methods we can use to present the discrete probability distribution. Right. Here also, the probability distributions, when we are looking at the characteristics of the probability distributions, there are two measures we are going to use to characterize the probability distribution. Now we will look at what are those for a discrete probability distribution and how we can calculate them for a discrete probability distribution. One is the expected value. That is actually mean. But when we are looking at for the probability distribution, that is for the probabilities we are measuring in future, what is the chance to occur this one? Right? When we are talking about the probability, usually we will not calculate the probabilities for the past events. We are trying to calculate the probabilities for the future events. So as a mean, because it's depending on the probabilities, we are using the terminology expected value, right, of a particular probability distribution or a variable. So here the mean actually, which is denoted by mu. For always the probability distributions, the mean is denoted by mu. But in the frequency distribution, means is denoted by, for the sample case, we are denoting by x bar. And for the population, we will use as a mu. But for the probability distribution, there is no sample or population. As a probability distribution, we will put it as a mu. Then mu, that is equal to E of x. This is the method of writing the mean for a probability distribution. Here E indicates expected value, right? And then in the bracket, what is the variable we are considering? That should be put within bracket. And how we are reading it? Expected value of x. That equals summation of, here x, this small x. These are the values taken by the random variable. So what are the values we are taking for random variable? On that we will add. How we are adding? X into probability of x. Here x is a numerical value and this probability of x is as the probability associated with this numerical value. Right? So mu is equal to expected value of x, that is calculated by using this formula, that is summation of x into p of x. Right. Now how we are calculating the sample mean or population mean for a frequency distribution. Put the formula in the chat box. As a frequency distribution, how we are calculating the mean value. You put it for the sample mean, how we are calculating the sample mean for a frequency distribution. Write in the formula as a chat box. Sorry. Only one thing here will be changed. When we are taking the sample mean, instead of probability of X, here we are taking a frequencies, right? X into F into X. Usually, the sample mean is calculated for a frequency distribution, summation of, there is also X values, X into Fi into Xi, right? Fi is a, or F into X. X is a, as a value data, that is, if we are taking the group class intervals, then Xi is a midpoint and the corresponding frequency. But when we are looking at the probability distribution, this formula will be applied. So therefore, first you have to understand the difference between the frequency distribution and the probability distribution, right? So when students are, when the students' papers, when I am marking the students' papers, usually I am finding for nearly 25% of the students are confusing with the frequency distribution and the probability distribution. Because in some cases, even the students are writing the formula. What is the formula we are using for the frequency distribution? That formula they are applying for the probability distribution also when calculating the expected value. So that is entirely wrong, right? So for the frequency distribution, Fi into Xi, but in the probability distribution, we are taking this formula. This is also, you can write as a Xi into probability of Xi. So X is the value of the random variable and probability of X is the probability of observing the value X, right? So now here we are taking a simple example. Now we're looking at this example, how we can calculate the mean value, that is expected value for a given problem. So here we have a probability distribution. This probability distributions indicates here X is the, right. Now you read this example and from this example, find out what is the random variable. Put in the chat box. Read the problem carefully and find out what is the random variable. Write your answer in the chat box. What is the random variable associated with this problem? Define the random variable related to the given problem. Could you answer in the chat box? Number of DVDs a person rents from a video store during a single visit. Right, that's fine. Very correct. Right? So, what is the random variable here? You can pick up that random variable from the given scenario. Here, compute the mean of the probability distribution to the right, which represents the number of DVDs a person rents from a video store during a single visit. For the number of DVDs persons rents a video store, so number of DVDs a person rents from a video store during a single visit, both are correct. Right? Okay. So now this is so the possible values taken by the, what are the possible values taken by the random variable? That also put it in the chat box. What are the possible values taken by the random variable? Put the possible values taken by the random variable. 0, 1, 2, 3, 4, 5. Right, that's fine. These are the possible values. So here there are only 6 values. So it's countable. So it is a discrete random variable. Right. These are the corresponding probabilities. Suppose now 0.22 means there is a 22% of chance that's a person rent rent 2 number of DVDs during a single visit. There is a 22% chance to rent 2 DVDs from a video store during a single visit. So these all are the related probabilities to occur these values. Right? Right. Now we have to compute the mean. So what is the, as a probability distribution, in the mean is denoted by mu, that is that is indicated by expected value E of X, where X is the name of the random variable that is given by summation of X into P of X. Then X is a value taken by the random variable 0 into the corresponding probability 0.06 plus summation indicates sum of all the multiplication of these terms plus 1 into 0.58 plus 2 into 0.22 plus 3 into 0.10 plus 4 into 0.03 plus 5 into 0.01. That is equal to 1.49. Right. Now, how do you interpret it? Based on these concepts, can you write the interpretation of 1.49 in the chat box? Take a 3 to 5 minutes time and think about how we can interpret, and then write, put your answer in the chat box. Now the expected value is calculated. Expected value is calculated as 1.49. What does this 1.49 tell you? Because the other people cannot understand the expected value of the random variable is 1.49, then they cannot understand. So how you can explain this value? Already you know how we can interpret the mean. Similarly, here also little bit different this one. This one is also mean, but small changes is there. Anyway, from your understanding, how you can interpret it. Put your answer in the chat box. First, you try to think about this 1.49 as an average. How we are interpreting the mean value for a frequency distribution. In such manner, you think about. Now, as a mean value, 1.49, you as a thing about as a mean, then you write the interpretation in the chat box. Right. Anyway, I will tell the answer. Actually, here 1.49 is average. So on average, right, as if we are taking as a mean value, on average, 1.4, on average, a person will rent or a person rents 1.49 DVDs from a video store during a single visit. On average, a person rents 1.49 number of DVDs from a video store during a single visit. But here it is expected. In addition to, we have to write it, it is expected. So it is expected that, right? It is expected that on average, a person will rent 1.49 number of DVDs from a video store during a single visit. Right? In the long run, how many DVDs a selected person will rent or will rent out from a video store during a single visit? That is here we are expecting this number of videos the person will rent during a single visit from the video store. So how now, in a simple language, how we are saying that it is expected, right? A person on average, or a person on average will rent 1.49 number of DVDs from a video store during a single visit. Only here we are adding the term, it is expected. Right? As a frequency distribution, after observed, we calculated the mean value. But here we are taking the percent probabilities. So the probabilities here we are taking as a weight. So more chance, we are giving more weight. So actually this expected value is a weighted average. So now here we are calculating the weighted average. The weighted, for the weights, we are using the probabilities. Right? So in future, we are expecting this number. Right? So it's expected on average, a person will rent 1.49 DVDs from a video store during a single visit. That's okay. Right. So now here, actually, what is the meaning? The mean of a random variable represents what we would expect to happen in the long run. That is in the future, what we would expect it to happen. It is also called, that's why it is called we are expected value of the random variable. Right? Then similarly, variance. What is the meaning of variance? That is the deviations from the mean value. Usually, as a frequency distribution, we are looking at how the data are deviated from its mean value. The squared deviations from the mean value. That is the variance. Variance is a squared deviations from the mean value. So here, actually, x minus expected value of x. This is the deviations from the mean value, because here expected of x is the mean value. So usually for the probability distribution, variance is given by or denoted by sigma squared. That is equal to summation of x minus expected value of x holding squared into probability of x. In that case, a frequency distribution, fi into xi minus x bar holding squared. Then we have a computational formula. Similarly, here also, this when we are simplifying this formula, we can get this sigma squared is equal to, because this is very difficult to calculate. So this is actual definition. From this definitions, we derived this computational formula. It is given by expected value of x squared minus expected value of x holding squared. Right? So now we know that expected value of x, that is actually mu, is calculated by this formula. Similarly, here we have to calculate to get this figure, that is expected value of x squared. So here instead of x, here we have x squared. Summation of x squared into probability of x. Right? So x is the value of the random variable and probability of x is the probability of observing the value x. Right? So here also, as a frequency distributions, we are looking at the average of the squared deviations from the mean. Average of the squared deviations from the mean. That is the variance. Similarly, here also, we are looking at the squared deviations, weighted average of the squared deviations from the mean. Here, the mean is denoted by expected value of a particular random variable. Then standard deviations, we have to take the square root. Sigma, that is standard deviation for a discrete random variable, is denoted by sigma. That is square root of positive square root of sigma squared variance. That is equal to expected value of x squared minus expected value of x holding squared. Right? Right. Now we are going to calculate the variance and the standard deviation for the example just before we considered to calculate the expected value, right? So we are going to calculate the variance and standard deviation for the probability distributions that represents the number of DVDs a person rents from a video store during a single visit. So for that, here we prepare a table like this kind of table, because we know that variance is this one, expected value of x minus e of x holding squared. This is same as expected value of x squared minus expected value of x holding squared. That is equal to summation of x squared into p of x minus sum of x into p of x holding squared. This is equal to this one. This is equal to this one. So we need x into p of x and x squared into p of x. So x, px. Then we are creating another column, x into p of x. So when we are adding all these things, that is 1.49. So x into px, 0 into 0.06, 1 into 0.58, 2 into 0.22. This one you will get. Then we need another one, this one, x squared into px. So again, this column should be multiplied by x. So 0 into 0, 0, 1 into 0.58, 0.58, 2 into 0.44, 0.88, 3 into 0.30. Similarly, we multiply this column by x, the corresponding x values. Then we add all these figures. Then you will get 3.09. So now we are going to substitute these values on the appropriate places. So summation of x squared into px, 3.09, minus this figure 1.49, that should be squared. So that is 0.8699. So to calculate the standard deviation, that is denoted by sigma, we have to take the square root, that is 0.93. So the average number of DVDs deviated from the mean value, deviated from the mean by 0.93. The number of DVDs rendered from the store will deviated from the mean by 0.93 units. That means the average number of rendered DVDs will lies between your mean value is 1.549 minus 0.93, comma 1.49 plus 0.93. It is expected that in the on average, how much it will deviate from the mean value by 0.93 units, right? So this is the same interpretations, but probability distribution we are calculating for future in the sample. What is the data collected? For that data we calculated, right? So what are the summary measures we learned? One is the expected value. That is mean of the probability distribution. It is the weighted average of all possible values. It is the weighted average of possible values. That is denoted by mu. That is E of x summation of x into px. Then variance. That is also weighted average of squared deviations from the mean or about the mean. That is denoted by sigma squared, defined as x minus mu, because mu is equal expected value of x. Here E of x is mu. Then that is summation of x minus, according to the definition of the expected, x minus mu holding squared into p of x, weighted average. So when we are simplifying this one, it is expected value of x squared minus mu squared. How we can calculate this one? That is summation of x squared into p of x minus mu squared. All these formulas you have to know that, right? Then standard deviation is we have to take the positive square root for the variance. So sigma is equal to square root of sigma squared. Right. Now here, read this example. And first you calculate the mean value and put your answer in the chat box. And also you can create the probability distributions as in the table, or you can create for the chat box. You can create the probability distribution in the list format. First you create the probability distribution for the given random variable in the form of listing. And put your answer in the chat box. So listing format means like this. Right? This format. In this format, create the probability distribution. It is a new random variable value and the corresponding probability. This is second random variable value, comma, and the corresponding probability. So in this format, you write the probability distribution for the given scenario first. Right. Here, when we are looking at this probability distribution, one thing you have to note that actually the random variable denotes the profit earned by this company, right? X is a random variable that denotes profit earned by this company. But when we are reading the first statement, based in its analysis of future demand for its products, the financial department company has determined that there is a 0.17 probability that the company will lose rupees 1.2 million. So here it is a loss. So in this case, what you have to put? Minus 1.2. It is a minus 1.2. And then the probability is 0.17. Similarly, there is a 0.21 probability that it will lose rupees 0.7 million. Here also you have to put minus 0.7 because our random variable X denotes a profit. If only profit, then you can put the positive value. If there is no profit and the loss, then you have to put the minus value. Loss indicated by minus. Right? Then it will lose minus 0.7. So that is minus 0.7. Then next two things are right. There is a 0.37 probability that it will make a profit of 0.9 million. And there is a probability of minus, 0.25 with a profit 2.3. So 2.3 and 0.25. Only you have to add negative values on this minus 1.2 and minus 0.7. Other things are okay. Right? Right. So here now I am looking at how we are creating the probability distribution of profit. The profit is denoted by X. So first we have to list the values random variable X, and the corresponding values are minus 1.2, minus 0.7, 0.9, 2.3. And the corresponding probabilities 0.17, 0.21, 0.37, 0.25. Then write the probability distribution. It is an answer for part A. Then part B, find the mean and the standard deviation of X. Then mean is denoted by expected value of X because here X is our random variable. That is summation of X into P of X. And it is better to have negative values on the bracket. Even this, when I am marking your first semester exam, on some of the students put the negative values in the bracket and they got the right answer. But most of the students, these are don't care students, right? They didn't use the brackets and all their answers are entirely wrong. Then they got the 0 marks. Because in the first day of your first semester lectures, I told that whenever you are dealing with negative numbers, please use the brackets. Otherwise, you will make the mistake. Right? The same thing happened. Only very few students, they followed the correct practice of mathematics and they got the full marks. But most of the students, they didn't use the brackets and all their answers are wrong. And then I never give any marks for them because they didn't the rules we taught in the class. So why we have to give the marks to them? Then they got the wrong answer and I didn't give any marks for them. So here also, please, if the negative numbers when you are dealing, put them in the bracket. Right? Then minus 1.2 into 0.17 plus bracket minus 0.7 into 0.21 and 0.9 into 0.37 and 2.3 into 0.25. When you are simplifying this one, you got 0.557. Then to calculate the variance, we need expected value of x squared also. So here we are calculating this one, x squared into probability of x, that is minus 1.2 square into 0.17 minus 7 holding square into 0.21 and 0.9 into 0.37 and 2.3 square into 0.25. Then calculate this, you complete this work, right? Find out this value. Then the standard deviation of x, that is denoted by sigma x, equals expected value of e x squared minus e of x holding squared. This value you can get from this value, and expected value of x already we calculated. This should be squared, and by taking the square root, then you can get the standard deviation. So you have to complete these two answers, right? Right. Then here, first you read this 3 minutes time I am giving, read this exercise and get the understanding for this problem. Right. Here are two product lines, line 1 and line 2. For both lines, they have to the same investment. To buy the both lines, they have to the same investment. Anyway, there is some probabilities of the market acceptance are there, right? The market acceptance, they divided, they rank the market acceptance as poor, below average, average, above average, and the excellent. So, and the corresponding probabilities for each and every line. So here actually this means if we want to earn 3,000 profits from line 1, the profit is 0.05 because it's a very poor market acceptance. So 0.05, and they for earn 3,000 of profit, the probability is 0.05. But from the line 2, to earn the profit 2,250, the profit is 0.05. If they want to earn 7,500 profit from line 1, the chance is 0.15. But similarly, for line 2, if we want to 3,700 earn, then the chance is 0.15. Similarly, for each and every line, they had the profits and the corresponding probability. Now, part A, you have to calculate the expected value and the variance of the profits for each line, right? And then from that one, you have to select which line has the higher expected profit and which line has the higher risk. So to find out which line has the higher expected profit, for both lines, you have to calculate the expected values. For line 1, separately, you have to calculate expected values. For line 2 also, you have to calculate the expected values, right? From that, which line has the higher expected value, that indicates the higher expected profit. Then for calculating the higher risk, that means there is a more variations. Which line has the more variations, then that line has the higher risk. So how we are calculating the variations? By using the measure standard deviation or variance. Another measure is possible. So to find out which line has more variance, that line has the higher risk. So for both line, you have to calculate the variances, right? Then from that, which line has more variance, that line has the higher risk, right? Then part B, which line would you select based on the coefficient of variation? So the coefficient variations we learned in the chapter 3, numerical measure, so chapter 4, I think, as it is a relative standard deviation, which is calculated by standard deviation over mean value. Here also, we have to apply that formula by using which one has the relative standard deviation, very less relative standard deviation, that one line is the best line, right? So here you note these things. So here I am taking for the line 1 profit as X, that is a random variable profit for line 1, and Y denotes the profit for line 2, right? Let X is the profit for line 1 and Y denotes the profit for line 2. So here I am marking X, Y, and it is for both lines, the market acceptance probabilities are same. That is P of X or P of Y. Then for the first line, I am considering the line 1, then expected value, because line 1 is given denoted by X. That is mu of X. That is summation of X into PX. You have to complete this one. Similarly, to get the variance, we are calculating expected value of X squared, because this one need, right? That is given by this one. And then by using these two measures, then we can calculate variance of X. That is sigma of X squared. That is E of X squared minus E of X holding squared. That means you can calculate. Then that is sigma X. And also we need, because for part B, we need coefficient of variance X. That is sigma X over mu of X. Standard deviation over mean. So you have to complete these things. And then similarly, for line 2, expected value of Y, because line 2 is denoted by Y, that is calculating summation of Y into P of Y. Then similarly, we calculating expected value of Y squared, that is Y squared into P of Y. And then we are calculating variance of Y, and then you have to complete this one, right? From these calculations, you can identify which line has the higher expected profit and the higher risk. And also you can recommend based on the coefficient of variance, which line you have to select, right? Then you have to complete this as a homework, right? Then some of the laws of expected value, right? So suppose we are taking X and Y are the random variables and C is any constant. then the following identities hold. That is expected value of C. C is a constant. If C is a constant, then the expected value also same as the constant. And when we are taking C into X, any random variable that is multiplied by a constant, then you can write this is same as, you can take out the constant outside of this one, then C into expected value of X. Then two random variables where you are having, and then when these two random variables are added, then it is same as, simply you can calculate the expected value for each and every variable, and then you can add the expected values. This is same as for the subtraction also. Then when we are multiplying two random variables, if these two random variables are independent random variables, then expected value of X, Y, same as expected value of X into expected value of Y. Only it is appropriate if X and Y are independent variables. Similarly, there are some formula laws for the variance, but for the constant, when you are taking the variance, that is 0. Because you know that if same values are there is no variations among the values, then the variance also 0. Similarly, here also, for constant value, when you are taking the variance, that is 0. And then for when the C is multiplied, or random variable is multiplied by a constant, then it is same as C squared into variance of X. Right? And variance of X plus C, that is equal to variance of X. Then when X and Y are independent only, but expectation, there is no need the independence for addition or subtractions. But when two variables are, when you are taking the variance for two variables with the addition or subtraction, variance of X plus Y is equal to variance of X plus variance of Y. Similarly, for subtractions also, variance of X plus variance of Y. But these formulas are only applicable when X and Y are independent random variables. Otherwise, you can't apply this formula. But also, you look at plus, here minus, but the final results both are plus. Right? So here one application for the applying the previous laws we have. Here we are having a monthly sales. It's have a mean value 25,000 and a standard deviation of rupees 4,000. So our random variable is a monthly sales X. Then expected value of X is 25,000 and the sigma X is 4,000. Then we are calculating the profit, that is multiplying sales by 30% and subtracting the fixed cost. So now here profit is calculated, which is based on the monthly sales and the fixed cost of 6,000. Now using these distributional values, we have to find the mean and the standard deviation of monthly profit. Right? So now you look at, we are taking X as a monthly sales and Y as a profit. Right? So then expected value of X, that is mu of X, 25,000 and the standard deviation is 4,000. Then the profit, which is depending on the sales, how we are calculating the profit, sales is multiplied by 30%. So 30% is 0.3 into X minus the fixed cost is subtracted 6,000. Now using these informations, you have to calculate the mean and the standard deviation for monthly profit. So expected value of Y, that is the mean. So that is expected of Y is defined as this one, 0.3x minus 6,000. Now here we can take the previous expected loss. So that is E of 0.3x minus E of 6,000. So that is equal to 0.3 into expected value of x. So for a constant, the expected of 6,000 is same as 6,000. Then 0.3 into expected value of x, 25,000 minus 6,000, that is 1,500. Then similarly for variance of y, that is 0.3x minus 6,000. That is because for the variance, when you are taking the constant, that is 0. So that is variance of 0.3 because it's not depending on x. So variance of 0.3x. But when we are taking constant, that is should be squared. So 0.3 squared into variance of x. Then variance of x, that is you get the standard deviation 4,000. So that is 4,000 square. Then to calculate the standard deviation, we have to take the square root. So when it is a multiplication, so each and every term we can take square root. So that is 0.3 into 4,000, that is 1,200. So now here this is a small example how we can apply the loss. If one variable is not and other variable is a linear combination of the previous variable, then based on that one, we can extend the expected value and the variance using the previous one, mean and the standard deviation, right? Right. Then the binomial distribution. Next one, we are going to, it's a theoretical distribution. So far, for a random variable, we learned, for a discrete random variable, we learned how we can create a probability distribution and how we can calculate the expected value mean and the variance and the standard deviation for a discrete random variable. Now, we are going to learn some theoretical discrete probability distribution. One of the theoretical discrete probability distribution is the binomial distribution. Right. It is also actually started with a random experiment, but in this special, we are calling as a binomial random experiment. So any experiment, if you want to say binomial random experiment, there are 4 characteristics we have to look at. One is the experiment is performed a fixed number of times, right? That means we are repeating the same experiment a fixed number of times, 5 times or 10 times or 20 times, right? And here each repetition is called the trial. For example, tossing a coin, that is one trial. If we are tossing a coin 2 times, then that is called 2 trials. If we are tossing a coin 10 times, then that experiment has 10 trials. Right? Similarly, we are examining the product is a defective or non-defective. If we are examining a one product, then it is a one trial. If we are taking 10 products or 10 goods or 10 items, and if we are checking 10 items, whether each and every item has a defective or non-defective, then that is a 10 trials. So if the same experiment is repeating several times, each and every repetition is called a trial. So for the first thing, the experiment is performed a fixed number of times or fixed number of trials. Then second one, the trials are independent. That means the outcome of one trial will not affect the outcome of the other trial. For example, we are tossing a coin, then the 2 outcomes are there, head and tail. either head will occur or tail will occur. Then the second time we are tossing a coin, again, either we can get tail or tail, head or tail. But the occurrence of the second outcome of the trial will not be affected by the occurrence of the first trial. That is called the trials are independent. Third one, for each trial, there are only two mutually exclusive outcomes. Only there should be two mutually exclusive outcomes. Tossing a coin is a perfect example. Right? That is, you can get only two outcomes. These two outcomes cannot occur at the same time. Right? So, head or tail. Similarly, another example, testing or identifying or examining whether the item is defective or non-defective. Right? So, whatever experiment, it has only two outcomes, and those two outcomes are mutually exclusive, then that is the perfect example for a binomial random experiment. Right? And these two outcomes are named as success or failure. Right? So, suppose we can name our, that is depending the given situation or your wish. Right? Now, we want to look at tossing a coin 10 times. How many times we are getting? Heads. Out of 10 times, how many heads we got? So, now here we are interested in the heads. So, we are naming obtaining head as a success, and we are naming obtaining tail as a failure. So, which outcome you are interested, then that outcome we are naming as a success, and the other outcome we are naming as a failure. When examining the lot to identify whether the items are defective or non-defective, we are interested in how many defectives find out of 100 products. Then defective is a success and non-defective is a failure. So, on which outcome we are interested in calculating the probabilities, then that outcome we are naming as success and other outcome we are naming as a failure. Right? Then the probability of success is fixed. That means for each trial of the experiment, it will not change. Right? The first time also to occur, the success is probability is P, and the second trial also, that is P, and the third trials also, it is P. So, the obtaining the success, probability of obtaining success is same for each and every trial. If these four criteria are satisfied, then that experiment is called a binomial random experiment. Right? The experiment has n number of fixed trials, usually denoted by n, number of n fixed trials. These trials are independent, and each trial has only two mutually exclusive outcomes, and they are naming as success and failure, and the probability of success is same in each and every trial of the experiment. These are the four criteria it should have satisfied for the binomial random experiment. Then binomial random variable. Right? The binomial random variable is a random variable that counts the number of successes in n trials of the binomial experiment. Right? The binomial random variable is a random variable that counts the number of successes in n trials of the binomial experiment. So, how we are defining number of successes in n trials. This is called as a binomial random variable. It is a discrete variable. We are able to count how many successes out of n trials. So it is a discrete random variable, and the probability distributions created for this random variable is called as a binomial probability distribution. For example, number of binomial random variable. These are the examples for a binomial random variable. Number of defective items in a batch of 5 items. So here the number of trials is 5 and the success outcome is defective and failure outcome is non-defective. There are number of correct answers on a 33 question exam, right? So here the number of fixed trials is 33 and the success is correct answer. The number of customers who purchase out of 100 customers who enter store, right? So here purchasing is a success, not purchasing is a failure. Then there are 100 number of independent trials, right? So each customer is, now here we assume that each customer is equally likely to purchase. So these are some examples for the binomial random variable. The main thing, there should be a number of fixed trials. Each trials are independent and there is only 2 possible outcomes for each and every trial, and the probability of occurring success outcome is same for each and every trial. If these 4 criteria are satisfied, then that is called a binomial random variable and the binomial experiment, and the random variable created that experiment is a binomial random variable. Here we can calculate the binomial probability distributions using this formula. This is a discrete probability distribution. For calculating the probability of getting X success. Now here X is a binomial random variable. This is a X number of successes. To get X number of successes from the N trials is calculated by this one. This is N combination X. That means out of N trials, how many X successes are there? Now when we are taking the tossing a coin 2 times, what are the possibilities? There are 4 possibilities. HH, HT, TH, TT. Right? So out of this one, how many times we can get 2 heads? 1 time. How many times we can get 1 head? 2 times. Similarly, here also, when we are tossing N times that coin, how many times we can get X heads? Suppose we are getting a coin 5 times. Then how many times we can get 5 heads? How many times we can get 4 heads? How many times we can hit 2 heads? To identify that number of times, we are using this formula. This is read as N combination X. That means out of N times, how many X successes we can get. Into P of X, it is probability of success in one trial, into Q, that which is raised to N minus X, that is 1 minus P. Q is a failure of the outcome, that is calculated by 1 minus P. Then how we can calculate this N combination X? That is N factorial divided by X factorial into N minus X factorial. Right? This X factorial, how we can calculate X factorial? Now you look at N factorial is calculated by 1 into 2 into 3 into up to N times. We have to multiply the numbers, positive integers from 1 to n, that is n factorial. So if we want to calculate 5 factorial, we have to multiply all the possible positive integers from 1 to 5. 1 into 2 into 3 into 4 into 5, that is 120. If we want to calculate 1 factorial, that is 1 into 1, that is 1. Also remember that 0 factorial is always 1. If we want to calculate 3 factorial, then we have to multiply 1 into 2 into 3. So, n combination x is calculated by this formula, n factorial, this one, then which is divided by x factorial, and then n minus x factorial. Here, n is the number of trials, x is the how many successes we want to get. Right? So what are the possible values for random variable, these x values? Because we are tossing n time, we are repeating the experiment n times. So the possible values are, for a particular outcome to occur, 0, 1, 2 up to n. When we are looking at the coin tossing one time, right? There are tossing 2 coins one time. We are tossing 2 coins one time. So there, the possible values for occurring number of heads, 0, 1, or 2. When we are tossing a coin 3 times, the possible values to head number of heads, 0, 1, 2, 3. That is the just Thursday class we looked at those examples. Similarly, if we are repeating the experiment n times, then the number of possibles to occur successes, x successes, is 0, 1, 2 up to n. So capital X is a random variable that denotes number of successes out of n trials. P is a probability of getting a success. Q is 1 minus P. N is number of trials. Usually, this factorial is calculated by using this formula. This is the method of presenting the formula by a formula. This is a probability distribution, discrete, but here we are using this formula. Right? Then some characteristics of a binomial distribution, parameters of the binomial distribution. Now, if you're looking at this formula, if we want to calculate to get x successes, the probability of getting x successes, we have to know the n and the p. If n and p are known, then we can apply this formula to calculate. Here, n is the number of trials and p is the probability of success. When we are tossing 5 coins, if you want to get the probability of getting 3 heads, then x will be 3. N is 5 and p is the probability of getting a head in one toss. That is, if it's equally likely, then p is half. So similarly, for any binomial random experiment, if we want to get x successes, then this n and p we have to know. So these, if we know these 2 things, then we can calculate any probabilities. So that's why these 2 things are called parameters. So the n and p are called parameters of the binomial distribution. Then when we are looking at the shape of the binomial distributions, it is symmetrical or skewed. Symmetrical means it is a bell-shaped curve and the one mode, and the mean, median, and mode all are same. Then skewed, there is the tails of the bell-shaped curve. Either right tail is longer than left tail, or the left tail is longer than the right tail. When the binomial distribution is symmetrical, when the probability of success is 0.5, it's not depending on the number of trials, right? So whenever P is equal to 0.5, the binomial distribution will be symmetric regardless of how large or small the value of n. Only the symmetrical is depending on the probability value. P is equal to 0.5. Right? So if the probability, that is both outcomes has equal chance to occur, equally likely both outcomes, then the binomial distribution is symmetrical. But when P not equal to 0.5, the distributions will be skewed. Right? If P greater than 0.5, then it is, I think it's right skewed, otherwise it's a left skewed. Right? Right. So here it is P 0.1. 0.1. It is for the small probabilities, it is a right skewed. Right? For the small probabilities, it is a right skewed. And when a P is equal to 0.5, it is a symmetrical. Right? Both sides you have equal probability. And for the mean and standard deviation, that is expected value, we can calculate by using those two parameters, N and P. For binomial distribution, the expected value is defined by N into P. N is the number of trials and P is the probability of success. And the standard deviation sigma is calculated by square root of NPQ. N is number of trials, P is probability of success, and Q is the 1 minus P. Right? Right. And then how we are denoting? Suppose a random variable X has a binomial probability distribution with parameters N and P. Then it can be denoted by X follows binomial N, P. The two parameters we have to specify. Right? So if you have a random variable X, it has a binomial distributions with the parameters N and P. N are the number of trials and P is the probability of success. Then we can denote this as X follows binomial with N, P. Then if it shows, then you can write in the next line, probability of X is equal to X is defined by N combination X, P to the power X into Q to the power N minus X, that is equal to N factorial divided by X factorial into N minus factorial, P to the power X, Q to the power N minus. Here also, you have to specify what is the values are appropriate, 0, 1, 2 up to N. So if we are asking to define a binomial probability distribution, then you have to write all these things. That is the full description of a binomial distributions, right? So suppose a binomial and variable X has a binomial probability distributions with parameters N and P. Then the binomial distribution is denoted by this one and is defined as this. Here, how we are going to calculate this formula is given by these two expressions. And also you have to specify what are the possible values if N and P are those parameters. And also you define what is X. That is, capital X is the number of successes. That is the binomial random variable. P is the probability of success and Q is equal to 1 minus P and N is equal to number of trials. It is the appropriate definition for the binomial distribution. And its mean is defined by N into P and probability of variance is defined by NPQ. Right. Now here we are taking an example 1. Now here there is each consumer has a probability of 0.25 of preferring your product over competitors' products. Right? There is a preferring the product product, probability of preferring a particular product over the competitor's product is 0.25. Now, we are taking 5 consumers and we are asking what is the probability, and we are interested in finding what is the probability that exactly 2 of 5 customers, what is the probability that exactly 2 of them prefer the product. Right? So now we're looking at this scenario as a probability, binomial probability case, right? So now, because we want to calculate the probability that, what is the probability of having 2 of them preferring the product. So it's like there are 5 consumers. Now we can consider it as a 5 number of trials. And there are preferring and not preferring 2 outcomes. And when we are asking the customer whether you are preferring this product or not. So there are 2 possible outcomes. Then each and every customer will not be affected. We are taking these 5 customers are independently answering. Right? And the probability of preferring that product customer is 0.25. That is, probability of success is 0.25. So now we are defining, take random variable X as number of consumers preferring the product out of 5 consumers. Because we need the calculator, we have to calculate such kind of probability that exactly 2 of them preferring your product. So let X equals number of consumers preferring the product out of 5 consumers. Then X has a binomial distribution with n equals 5. X has a binomial distribution with n is equal to 5. So that means, and P is equal to 0.25. Right? So the probability of preferring the product is 0.25. So now here our variable preferring the product. So X has a binomial distribution with n is equal to 5 and P is equal to 0.25. That is, X follows binomial distribution with 5, 0.25. So the probability of X equals X given by n rather than n. Here we have 5x. Then probability of success P is 0.25x into 1 minus P, 0.75 into n minus x, 5 minus x, where the values of x are 0, 1, 2, 3, 4, 5. Now, we have to calculate the probability. What is the probability? 2 of them prefer your product. So, Px equals 2. Right? How many consumers are preferring? Now, we want to calculate the probability. What is the probability that 2 consumers are preferring the product? So, x equals 2. So, whatever x value from 1 to 5 taking, we can calculate the probability by using this value. But for x is equal to 6, we cannot apply this formula. Right? Only these values we can calculate the probability. For x is equal to 7, we don't know. Only for the 5 customers here we consider. Out of 5 customers, we can calculate this probability. So we don't know for the 6th customer what will happen. Right? So within whatever value it's taking, then customers' numbers, then we can calculate by using this formula. Then 5 combination 2 is calculated by 5 factorial divided by 2 factorial into 3 factorial. When we are simplifying this one, you can find out. 4 into 5 divided by 2 into 0.0625, this square, and this is 0.753, that is 0.429. You calculate, approximate these probabilities for the 4 decimals, because finally we have to calculate this one in the percentage. So for the percentage, we have to get 2 decimals. then you are simplifying this one, 0.2637, that is 26.37%. So that means there is a 26.37% of chance probability that exactly 2 of 5 consumers will prefer the product. Out of 5 consumers, there is a 26.3% of chance to prefer 2 consumers will prefer this product. Right? Then your part here, you have to use calculators to calculate this one. In your calculator, there is a, you can calculate this term, 5 combination 2. And also there is a in the calculator, you can find out this figure, and also this figure you can calculate. So by using calculator, you have to learn how we can calculate the binomial probability, not the table. You have to use the calculators, right? There is a key to calculate this combination, factorial values. This exponential you can calculate. This exponential also you can calculate. So you take the calculator and learn how we can calculate these values. Right? That part I am leaving as homework. Then the mean and the standard deviation already we learned. Right. Now here also this example I am taking to explain this one, how we can calculate this one. Right? It is also customers test. We want to, there is a 2 soda. There is a one is a brand name, branded soda, and other one is the generic soda. And in a taste test, they want to identify whether the customers are able to identify the branded soda based on the, by looking at the taste, whether they are able to identify the branded soda. Right? So previous records indicate that 25% of the testers can distinguish between the 2 generic soda versus branded soda. So to identify whether 25% of the testers are able to identify, they are taking the, to identify how many out of 10 testers, how many are identifying the branded name soda. Right? So 10 times this test is repeated. So there are n fixed number of trials identifying the correct one or not identifying the correct one. That's the 2 outcomes. And identifying the correct guess or identifying the correct branded soda is 25%, 0.25. This is the probability of success. And these tests are done independently in separate locations. So each tester will not influence the other one. So these 10 customers are independent. So the trials are independent, right? Then the count of correct guesses in 10 tests has a binomial distribution. So in this case, the binomial random variable is the count of number of correct guesses in 10 test. So from this first question, what is the success outcome and the failure outcome? Right? So now here, according this problem, now we are defining let x is equal to the count of correct guesses in 10 test. Number of correct guesses. Then your success outcome, correct guess, and the failure outcome, wrong guess. Second one, what are N and P? So first, whatever problem you are having, first you have to identify the random variable and define the random variable using the capital letters X or Y, right? Usually we are taking X or Y. So first step, that one you have to do. Then you have to start to write the answers. Second one, first question, what is the success outcome and the failure outcome based on this one? Correct guess and the failure outcome, wrong guess. What are N and P? N is equal to 10. Yeah, because 10 times it was conducted, and P is equal to 0.25. That is identifying the correct guess. Identifying the branded soda is the correct guess, that is 0.25. Then according to the given scenario, X has a binomial distribution with parameters 10 and 0.25. So if X follows a binomial distribution 10, 0.25, then we can write probability of X equals X, that is 10 combination X, N is equal to 10, then P is equal to 0.25X, and 1 minus P, 0.75, 10 minus X. Then the possible values for X, that also you have to give in here. You have to give here 0, 1 up to 10, right? Then it is the answer for 2. Then answer, to calculate the other answers, we have to write this one. Then what is the probability of exactly 5 correct guesses? Exactly 5. Then Px equals 5. That is 10 instead of X, small x, now we have to write 5. Then use the calculator. You have to get the formula, apply the formula, and that is 5.84%. That means there is a chance of 5.84% that 5 customers, exactly 5 customers, guess the correct or give the correct guesses. 5 customers, there is a 5.84% of chance that 5 customers correctly identify the branded soda out of 10 customers or 10 tasters, right? Here, tasters, right? Then second one, what is the probability of at least 2? Here the word, you have to get the meaning of word, at least 2. That means at least 2 means minimum 2 customers. Minimum 2 customers, 2 tasters will identify, or more than 2, but minimum 2. So then how we are writing? Probability of X greater than or equal to 2. Minimum 2, right? So probability of X greater than or equal to 2. So this is same as X is equal to 2, X is equal to 3, because maximum value 10. So we can write probability X equals 10. So, but there are nearly 8 terms are there. So it is very difficult to find out the probability. It will take long time. So to make these calculations in a short time, or 1 minute. Okay, right? So probability of x greater than or equal to 2. So that is x equals 2 plus x equals 3 up to x equals 10. So here actually what happened, it takes long time. So because we know that total for any probability distribution, the total probability is 1. So here we have to need the probabilities 2 to 10. So only the terms are left for 0 and 1. So from the total probability 1, if we subtract these two probabilities, then you can calculate that this is same as probability of 2 to 10. So then you complete this one. So x is equal to 0. If you want to get the probability for x is equal to 0, that is 10, 0, 0.250. Then you substitute the values for x is equal to 10 as we did here. So how we are calculating for x is equal to 5? Similarly, apply that formula for x equal to 0, then apply that formula for x is equal to 1. From that, you can calculate the probability. Right. Then part 5, what is the probability of at most 3? Okay, at most 3 means maximum 3 correct guesses. So it may be, we can't exceed 3, maximum 3. So it may be 0 or 1 or 2 or 3. At most 3, right? So here also probability of x is equal to 0, x is equal to 1, plus x is equal to 2. And also here we make it as, wait a minute. Right. So probability of x less than or equal to 3. So here calculate the probability 0, 1, 2, 3. Then each and apply for formula for each and every term and then add all the probabilities. Right. So these all are the mutually exclusive. That's why we are adding 2 or 3 or 10. Right. Here 0, 1, 2, 3. Already you calculate for 0 and 1. Additionally for 2 and 3 you have to calculate. Then what are the expected value and standard deviation? Expected value n is equal to 10 into p 0.25, that is 2.5. So on average, it is expected that 2.5 customers identify the branded soda out of 10 tasters, right? It's expected on average 2.5 testers or tasters, on average 2.5 tasters identify the branded soda out of 10 tasters. Then standard deviation is square root of NPQ, that is 10 into 0.25 into 0.75, that is 1.37. So, that means please mute your mic. There is this mean value, that means the testers identifying the correct guesses deviated from the mean value by 1.37 units, right? Then this exercise, the previous expected value exercise, what are the exercises here I am leaving as a homework up to Poisson distribution. We will have lectures on Monday morning 10:30. So when you are coming to the Monday morning 10:30, this exercise, all these exercises you have to complete and bring the answers to the class, right? So if you have the answers on the class, then we can check those answers, right? After that, we will continue our lectures. And also when you are coming to the Monday 10:30 class, physical class, you have to all must have the calculators, right? Without calculators, don't come to the class. You can't use the phone as calculators, right? Non-programmable calculators you have to bring, right? There's a scientific calculators, FX100 or FX99. Those kind of calculators you can bring to the class, but phone will not be used, right? And also without calculator, don't come to the class. These are the rules you have to follow from the previous, from the Monday lectures onwards, right? In all the forthcoming lectures, you have to come with the calculators because we want to apply those calculators to find out the answers, right? So when you are coming to the Monday morning, complete all the exercises, right? In the binomial distribution and in the expected value and the discrete random probability distributions. What are the exercises we left as homework? Complete all the exercises. Today I will upload the lecture note, this lecture note, right? And then from that you can check it and then bring the answers. Now in the 5 minutes I will upload this one, right? So Monday morning 10:30 we will meet on the physical class, right? Thanks for coming the lectures. And any doubts if you want to ask, then you can clear the doubts. Otherwise, I can end the meeting. Right, okay. I'm going to stop my sharing. Thanks for attending the class.